This is the last of our examples involving related rates. We're going to look at similar triangles one more time. The spotlight on the ground shines on a wall 11 meters away. A man, 2 meters tall, walks away from the spotlight towards the wall at a speed of 1.3 meters per second. How fast is his shadow on the wall decreasing when he's 4 meters from the wall? So let's put in information that does not change, variables for things that do. The spotlight is 11 meters from the wall. So the spotlight to the wall is 11. The man is 2 meters and is not changing in height. The distance from the spotlight to the man is changing as he walks away from the spotlight towards the wall. The shadow is changing as the man gets closer and closer to the wall. So variables for things that change, numbers for things that are constant. Time for the equation. These two triangles are similar. They are similar because they both have a right angle and they both share this angle in the corner. That means the third one is also a match, and so one triangle is the same as the other in terms of the ratio of the sides. So if we set up the ratio, y over 11 for the big triangle, that would match 2 over x for the small triangle. So vertical compared to horizontal, vertical compared to horizontal. We now have an equation. To relate the rates, we're going to take the derivative. You can take the derivative the way it looks, or we could get rid of these fractions and end up with this instead. Multiply both sides by x will give us xy. Multiply both sides by 11 will give us 22. Up to you if you wanted to do the derivative this way or this way. The answer will be the same in the end. Let's keep going. Derivative of the left-hand side with respect to time, because time is in the denominator, and we have a product rule here. So we'll take derivative of first times second, plus first times derivative of second, and the derivative of the number 22 is just 0. So the derivative of the first, derivative of x with respect to x is 1, chained with dx dt, times the second, plus the first, the derivative of y with respect to y is just 1, times dy dt, and the derivative of the constant number with no variable is just 0. What is it we're looking for? How fast? That means we're looking for d's. Shadow on the wall. So how fast is y changing? We're looking for dy dt. So let's get this term by itself. Let's take the dx dty to the other side, making it negative, and then divide both sides by x. Now, filling in what we know. How fast is the shadow on the wall decreasing when he's 4 from the wall? So if he's 4 from the wall and the distance is 11, what's x? You can fill that in. To find y, we're going to go back to the equation just before we took the derivative. You should have found that x was 7. If the person is 4 from the wall, the total distance was 11, that means x would be 7. When you solve that for y, you're going to get 22 over 7. We can then put that in for y, putting 7 in for x, and then we'll see what else we know. And again, for those wondering where the 7 came from, how fast is his shadow decreasing when he is 4 meters from the wall? When he's 4 from the wall, the total distance is 11, it means he must have walked 7. Let's put those numbers in. The 22 over 7 is in for y, the 7 in for x, and dx dt was how fast that distance is changing, and that was the speed of x, which is 1.3. Now let's clean that up. If we multiply top and bottom by 7, that'll get rid of that 7 in the denominator. We get negative 1.3 times 22 over 49. Now you don't leave decimals and fractions in this messy looking like this. If you just have numbers, it's okay to leave it as a fraction if you just have integers. But when you have decimals, you might as well just move to a decimal. So the shadow decreasing. Why was it decreasing? Because of that negative. Decreasing at 0.583. Y is a distance that's measured in meters. Time is measured in seconds. So that's why it's decreasing at 0.583 meters per second. And we'll see if that makes any sense. The spotlight casts this kind of a shadow. As you move closer, the spotlight will cast that sort of shadow. So it looks like Y should be getting smaller, so this should make sense. I'll go over that again for those who need to see it. Shadow on the wall changing gets a variable. Distance between spotlight and man gets a variable. The man is 2 meters, that's constant, we put a number in. Distance between spotlight and wall is 11, that's a constant, that gets a number. The two triangles are similar, so we can set up a ratio. Vertical to horizontal in big triangle, vertical to horizontal in small triangle. Up to you if you want to take the derivative now, or if you want to rearrange it so that there's no fractions. This will be a product rule when we take the derivative. Derivative of first times second plus first times derivative of second. Derivative of a constant is 0. We were looking for the speed of change of the shadow, so that would be dy dt. We'll get dy dt by itself by getting that term to the other side. It will become negative when we do that. Then divide by x. And we found x by doing some work here. 4 meters from the wall, total distance 11, that would make x 7. And if x is 7, y is 22 over 7. We put those numbers in, and the 1.3 came from the speed of the person walking, and that would be how fast that distance is increasing. Cleaned up the fraction by multiplying by 7 over 7. And then because we have decimals as part of fractions, we just went to a decimal answer. Your job now. Today I would finish review number 2, and after that just do all the work that you see in that package. The Turvy at the end is one of my favorites. I think you'll enjoy doing it. And when you decide you're ready, you should write the test for chapter 3. If you have any questions, let me know.